Assalamualaikum warahmatullahi wabarakatuh and good day to our lecturer for Geology Engineering course, Technologies Mak Fairuz bin Yusof. Today we would like to present our project for tropical weathering classifications. We are from Group 1, Session 8. This project will be presenting by 5 members of our group, which are Nur Atika binti Faizul Kamar, Siti Atika binti Muhammad Zain, Aimin Najla binti Ahmad Tazli, Normizatul Anissa Johalmi, and Siti Mastura binti Rahman. Basically, there are 5 contents in this presentation that will be presented by us. For introduction, the tropics are those places in the world that are roughly in the middle of the globe, and the tropics cover 36% of the Earth area and are home to roughly 1/3 of the world's populations. And it was remain hot all year, with temperatures range from 35 to 38 degrees Celsius, which are 77 to 82 degrees Fahrenheit. Basically, in tropical group, there are 3 climate types, which are tropical wet, tropical monsoons, and tropical wet and dry. For places with tropical wet, it also known as rainforest. For Malaysia, Malaysia is located in the equatorial regions and has a tropical rainforest climate. By the way, the rate at which rocks weather is affected by rainfall and temperatures. Chemical weathering is accelerated by higher temperatures and more rainfall. Therefore, tropical rocks in Malaysia, for example, which are exposed to a lot of rain and hot temperatures, it was weather significantly faster than equivalent rocks in cold and dry climate. The high temperatures, heavy rainfall, and humidity of tropical regions have driven chemical weathering to the extreme. Basically, there are 3 types of weathering, which are physical, chemical, and biological, and all these weathering processes have a certain importance, but chemical weathering plays the most relevant role in the disintegrations of minerals and rocks in the humid tropical zones. The rate of weathering depends on the types of rocks. Rocks in tropical climates, in Malaysia for example, experience the highest rates of weathering because of the combinations of high heat and heavy rainfall. Therefore, it is crucial to be able to identify the weathering classification in tropical region, as it's been developed for engineering geological purposes that also derive from the classification for engineering purposes.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aimin Najla binti Ahmad Tazli. I will present for literature review. For the suggested profile contains thickness, topography, color, and genre requirements for a variety of recognized mass weathering grades based on ISRM 2007. A wide variety of weathering stages, from new rock to residual soil, were depicted in the profile. In the weathered zone, rock matrix weathering begins with discoloration of rocks along the skin tonality surfaces. The rocks in this zone range in hue from light pink to light grey. In this zone, where more than 50% of the joints are vertical, 4 primary joint sets are expected. Furthermore, the average joint spacing and trace length are around 0.5 and 3.5 meter respectively. The somewhat worn rock can be up to 8.5 meter thick. For moderately worn zone, less than half of the rock matrix is dissolved or disintegrated to the soil. The rock in this zone is light brown to dark grey in hue, and there are just 4 joint sets total, with fewer than half of the joints being vertical. The joints' mean spacing and trace length are around 0.4 and 2 meters respectively. The zone can be up to 6 meters thick. The presence of coalstone divides the severely weathered zone into 2 classes. Firstly is if there are coalstones in grade, then secondly is but none are visible in grade. The presence of coalstone distinguishes 2 grades in the fully weathered zone. The consistent weathering in grade A leads to a progressive reduction in weathering to a depth where no coalstone can be detected. The presence of coalstone surrounded by decomposed rock, on the other hand, disrupts the grade's weathering homogeneity B. Although all rock matrices degrade to soil, the original structure of the rock mass is frequently retained in this zone. Parent rock fully dissolved to the soil in residual soil. As a result, no rock texture or bark has been retained. Vegetation may be partially covering this zone. This zone has a maximum thickness of 4 meters.
Assalamualaikum. I'm Siti Atika binti Muhammad Zain, and now I would like to present about the methodology. First of all, the methodology of weathering classification is based on the LLV 2015 journal. From the journal, such study is included observation and joint survey, such as orientation, joint spacing, and trace length into region of weather granitic rock. The study site including 11 panels in Masai Quarry and 13 panels in Puteri Wangsa Quarry. Wide range of mass weathering grades present from fresh rock to totally weathered rock. For joint investigation, scanline and window survey sample technique are commonly used, but for this study, the researchers are used a scanline method to measure the joint characteristic because this method is more easier to use and give more detailed data compared to window technique. The last one, for orientation of the joint is including deep angle, deep direction, spacing, and trace length were surveyed for mass weathering grade.
Okay, I will continue with the results and discussion. My name is Siti Masrur Hafidurrahman DF200118. In this study, we will discuss about the joint orientation, mean joint tracing, mean spacing, length, and the lastly is the joint inclinations. Okay, the joint orientation. When we look at figure 3, Masai Quarry having two topography. Blue color A to H is side plane and the red color is trace panels, which is I to K. Okay, while Puteri Wangsa Quarry having three topography. Red color trace panels A, B, C, K, L, M. Blue color for side panel D, E, I, G, and purple color is belly panels F, G, H. Next, cornerstone were also identified in both sides using geological feeders. In Masai is panel B, C, D, E, G. Meanwhile, in Puteri Wangsa is panel A. They also have normal fault, which is panel FGH in Masai and AIK for Puteri Wangsa. Mean spacing for granite in different mass weathering grades can be referred in figure 3. From the results, mean joint spacing decreased from fresh 1.57 to slightly weathered zone 0.61, then decreased to moderately weathered zones. Lastly, increased through hardly weathered to completely weathered. The maximum mean of the joint spacing occurs in fresh rock, meanwhile minimum mean of joint spacing found in moderately weathered rock. Mean trace length. From the graph, a slightly decrement in mean trace length occurs from fresh to slightly weathered rock, then sharp decline to moderately weathered. Lastly, continuous decrease to completely weathered rocks. The overall trend is decreasing along weathering progress from fresh to completely weathered rocks. The lastly is result for percentage of joint inclinations. From the weathering process, increasing trend in percentage for horizontal joints, decreasing trend in the percentage of vertical joint, while inclined joint fracture in different mass weathering grades. That's all from me, and I will pass this presentation to my other members.
Hi, my name is Atika Bitpesukama, so I will continue the conclusion. Alright, weathering effect may vary from place to place because of rock types and structure, topography, rate of erosion, and regional climate variations. So weathering is more intense in tropical regions due to heavy rains and hot and climatic conditions, which develop weathering effect to greater than elsewhere. So the classification system of geology have been qualitative descriptions of weather rock masses which are typically related to granitic rocks. Propose that the dominant mass weathering profile for granitic rock in Peninsular Malaysia are types A and B. So the main difference between these types is the distribution of cornerstone in and different weathering zones. This issue is more important in tropical climates where severe weathering produces thin weathering profiles. So thin weathering profiles are normally classified or graded differently based on some field observations, geological studies, and material properties of rock. So it believed that the proposed weathering profile may contribute to engineering design and classification of weather granitic rock in tropical region. So another finding of present paper was the relation between joint inclination and mass weathering grade. A tropical profile was proposed based on descriptions of joint categorization, topography, and geological condition, and also the rock appearance. It includes a complete range of weathering from fresh to residual soil and to subgrades for completely weathered and hardly weathered zones. Thank you.